Hey everybody, Mr. Barry here. Again, talking about standard form of quadratic function. We know that's y is equal to ax squared plus bx plus c. It's the third of three different types of forms that we've talked about when it comes to quadratics. It's the one that's most clarified, or there's less math work to be done up there. But for the same token, we probably have a little bit more math work to do when it comes to graphing here. So let's go ahead and start. I got y is equal to negative 1/2 x squared plus 4x minus 3. Always a good idea to start off writing down what my a, b, and c is. Here in this problem, a is negative 1/2. It's the coefficient with that variable squared. We have our b value is 4, and our c value here is negative 3. And with standard form problems, the easiest thing to figure out here is the y-intercept. The y-intercept will be the c value within the problem. So in this case right here, we know we already have a point at 0, negative 3. As much work as we have to do, the y-intercept is the easiest thing to check out here. And I want to go ahead and graph it at 0, negative 3. So I'll go ahead and put a dot right there. I don't want to put it in the table quite yet because I want to see how everything interacts. Because after I figure out the y-intercept, it's a great idea to go ahead and calculate what the axis of symmetry is, as well as figure out what the vertex is. So we're going to go ahead and do that next. Next up is the axis of symmetry. As part of the vertex, we know we have a formula for that we can always use, which is negative b divided by 2a. In this situation, we've got to be kind of careful. Not only do we have a negative a value, but we also have a fraction. So we just got to be kind of careful with how we place things. Want to make sure you use parentheses. Our b here is 4. We have the 2, and then we're going to multiply that times negative 1/2. So again, be careful here. Got to do 2 times negative 1/2. 2 times a negative half would be negative 1. Negative 4 divided by negative 1 would be positive 4. So we know we have an axis of symmetry here for this problem of x is equal to 4. I'm going to go ahead and draw that in my picture. Again, it's that vertical line that we know is not really there, but we like to kind of draw it in as a dotted line so we can use it as a mirror within the problem. And we also know that that axis of symmetry is going to be the x value for our vertex. I'll put it in the middle of my table here. And now I'll put down my y-intercept as well. Try to start kind of piecing together things and maybe use that mirror the first time. I know I have the point 0, negative 3. For that y-intercept, the 0 is 4 spots away from the axis of symmetry. On the other side of it, 4 spots away would be an x value of 8, and that should have the same exact y value. So I'm going to go ahead and plot that point right there, 8 comma negative 3, 5, 6, 7, 8. And I already have 2 points on the graph. To get the third point, I want to finish out the vertex. We already have the axis of symmetry is 4. I'll take that 4, plug it into the function, do some math work with that. So negative 1/2, and I'm plugging in a 4 wherever I see the x value. Again, that's coming from my work on the axis of symmetry. 4 squared would be 16. 16 times negative 1/2 would be negative 8. 4 times 4 is 16. Got that negative 3 out there. And our y value for the vertex would be the number 5. So for our vertex here, 4, 5 is our point. I'm going to go ahead and put that in my table, finish that up, and graph it on the graph 4, 5. 1, 2, 3, 4, 5. Right there would be my vertex. And because we have a negative a value, we know it would be a maximum in this case. Finally, I want to go ahead. I need 2 more points to make this kind of look as good as possible and have as much information on it as I possibly can. Again, I could pick any x value number that I want and plug it in here, but I kind of want to be smart about it. I want to make sure that it makes sense within the context of the problem. So if I pick a number like 20 for x and plug that in, I'm going to probably get a point that's not on the chart. Got to be kind of use a little bit of thought here about this. I have 0, I have 4, I have 8 for the x values here. I'm just going to go ahead and choose 2 You could choose 1, 2, 3, 5, 6, 7. You could use a decimal value if you really want, but I'm trying to make this easy for myself, so I'm going to put in a 2 for an x. I'll figure out what that is for a y value. So again, I'm plugging it in to the function. Got to do a little bit of math work, although we're certainly able to plug this into a calculator if need be. 2 squared is 4. 4 times negative a half would be negative 2. 4 times 2 is 8. Got the negative 3 out there. And we get a y value of 3. So I randomly chose 2 to plug in. When I did that, I got a y value of 3 back out. See if it makes sense here. 2 comma 3 right there. Looks as if it could certainly be a part of the parabola. We'll use the mirror on the other side of that axis of symmetry right there at the spot 6 comma 3. I now have 5 points right here. I got 5 points on the graph. I'll be able to connect the dots and have a pretty good looking parabola here. So again, process-wise, not a bad idea to start off by writing down A, B, and C, figure out a y-intercept, get the axis of symmetry, use that axis of symmetry to mirror the y-intercept, finish it out and get the vertex, and then finally pick one more point to plug in for x, get a y value and mirror that point as well in order to get 5 points for this parabola.